Hello everyone, welcome to another one of my Leetcode videos. In this one we'll do today's daily challenge 1519, number of nodes in the subtree with the same label. So this input format is quite similar to the yesterday's daily challenge, so it'll pop up on the top right. If you haven't checked that out, go check it out, but it's not absolutely necessary. So yeah, with that, let's get into this one. So basically we're given a tree and the tree has a certain amount of labels, right? And we need to determine for each node how many nodes in this subtree has the same label. So for example, for node number 0, in this tree you have two nodes with the letter A, 0 and 2. So that's why the answer for 0 is 2. In the node number 1, in this tree for the node number 1, only one node has a label of B. So that's 1, and so on. Same thing for everything else. So what will be our approach here for solving this problem? So basically what we'll do is for each node we'll try to get a frequency count or a character count. So basically it's a map of character to the number of times the character occurs, and that will be for this tree, right? So for this node what we'll do is we'll first get the character map of the subtree, right? So in the subtree's character map for this node we'll see that B1, D1, C1, and then we'll get the character map of the other subtree. We'll see A1, E1, D1, and then we'll combine those maps, character counts, and then add this one, right? And then finally, whatever the count of the letter A is, or the current node's letter, that will be put into our answer. So in this case, since the character count of this subtree will return A1, when it's combined with this, we'll have A2, and then we'll assign answer array to 2 for this node. And we'll do that for every node as we traverse the tree. So let's get into the coding. So similar to the previous video, we were given an array of edges where each edge is A, B. And again, this is just sorted, so it doesn't necessarily mean that A is below B. So we need to convert this into an adjacency list where we have a map of the node to the children of that node. So let's go ahead and create that map. So here we have it. It's just our adjacency list. We go through each of the edges and we initialize a new linked list if it's not already present for that number. And then we insert edge 1 corresponding to edge 0 and vice versa. So this gives us our adjacency list. Now let's just go ahead and instantiate our answer array. So we'll have, so this is an array of size n for our answers, and then we'll go ahead and call a recursive function which we'll write in a second. So I've gone ahead and defined the recursive function. Basically it'll return a map of character to integer, because for each subtree, remember, we need to get their maps and then combine them. And so it'll take in the index for which we want to get the character count at. It'll take in the adjacency list and the set of nodes we visited. And the reason we need this is because the adjacency list may contain a pointer to its parent, right? Because we're storing both directions. And so we don't want to traverse the parent, so we need to keep track of what we visited so that we don't revisit it as a child accidentally. And then obviously we have our labels, which will tell us which node has which label. And then we have our answer array, which is what we'll end up populating. And then up here, we'll just call that function, and at the end, we'll return answer. So now let's go ahead and write our recursive function. So the first thing we'll do is basically add the I to our visited array, because we already visited this node, and so we want to keep track of that. Next, since we need to return a character count for this node, we'll go ahead and instantiate that map. Okay, so here we have our map, and at the end, obviously this is the map that will be returned. And now we just need to loop through the children, right? So we loop through the children, get their respective maps and combine them, and then at the end combine it with the node, right? So let's loop through the children first to see how that goes. So I've created here a loop that loops through all the children of the node I, And the first thing obviously we do is we check if we've already visited this child. It means that it's not actually a child, it's the parent. And so with that one, we just ignore because we don't want to traverse the parent, obviously. And so now at this point, what we do is we'll call our recursive function for this child. So here we have it. I've made the call to our recursive function and I realized I called this differently here, so I'll fix the name. So we call our recursive function for the child to get the child's character count. So this will give us a map of character to integer for everything in the child subtree, right? And now that we have the child's character count, what we have to do is aggregate it in our parent character count. So we'll just loop through all of the entries in the child's character count. So here we have our loop that just loops through each entry in the child's character count. Next, let's save the variables for the character and the occurrences. So here we have the character and occurrences of that saved, and now let's aggregate it into our current map. So what we'll do is, if it already exists in the map, that means a previous child also had it, then we'll add the occurrences of this child to the one that's already there for this node. Otherwise, we'll just set it to the occurrences. So here we have it. Inside our character count for the current node, we're putting the character as the key, and the value is, this is the existing count. So we get the count for the character and default to 0. That's the existing count plus the occurrences, right? So this will basically calculate the aggregate count for this parent node. And now that the character count here has already aggregated everything, all the characters from all the children, now what we need to do is just add the current node's value to this character count. So we'll do a similar thing as we did here. So here we have it. We get the current node's label, that's just labels.caret_i, and then we update the map with the current node label as the key. And if the current node label already exists, that means it could be somewhere, there could be counts in its children. We get that count, otherwise we just default to 0, and we add 1 for the current node, because that node is also part of the subtree. So now this character count for this node I will have the full character count of the whole subtree. So then what we just have to do is, in our answers array, we store the character count for the current label. So we'll have answers at I, which is the node we're traversing, is equal to the character count dot get of the current node label. That will be the answer. And so just taking a recap here, as it visits each child, each child will get its own map, right? So when it comes at the bottommost node, you'll notice that it'll have no children. This will be an empty map here. And this over here will get just the current character, and it will be added as 1 in the answers array, right? So since this recurses for each children, we are guaranteed to visit each child. And here we check that, we don't visit the same thing twice, obviously. And we're guaranteed that there are no cycles. So basically, we'll end up visiting all children and then populating their answers array this way. So this is basically a DFS plus recursive type of solution. So now let's run the code and see how this does. Oops, I have a compilation error on line 49. I just called it answer. So this is just answer. Cool, all accepted. Let's submit. Perfect. Thank you so much for watching. I'll see you in the next video. Cheers.